Hi everyone! If you are working with security logs, threat hunting, or just trying to make sense of network data, you know how frustrating slow queries can be. Today I am going to show you 5 KQL tricks that will immediately speed up your hunting and make your analysis more effective. We've all written queries that take forever to run or return results that are hard to interpret. But what if I told you that with a few simple changes, you could make your queries 5 to 20 times faster while getting better, more actionable insights? In this video, we are going to compare bad versus good KQL queries side by side. For each trick, I will show you the slow, inefficient way that most people write queries, and we will reveal the optimized version of professional threat hunters use. We're working with the real network log data here, so these are practical examples you can use today. Whether you are hunting for malware, detecting port scans, or analyzing attack patterns, these tricks will save your time and help you find threats faster. So let's dive in. Okay, let's start with trick number 1, detecting anomalies in packet size. This is crucial for finding data exfiltration or large payload attacks. Here's the bad version that I often see. It uses extent with a complex case statement before filtering. It processes every single record through multiple conditions. So the result is just a table of numbers that is really quite hard to analyze. Now let's check what we can change here. Now it looks much better. We filter first where payload size is higher than 3K. This immediately reduces our dataset by 95%. We use mindful aggregations and get a clear visualization too. The query runs 10 times faster and gives actionable insights. This is something which you can present in your report for the management. The key lessons here: always filter before your transfer. Your word clause should come before extent or any calculations. Trick number 2 is about detecting port scanning, one of the most common reconnaissance activities. Let's have a look on the bad query first. As you can see, it uses multiple OR conditions, where you can see port 80 or port 443 or port 22, 21, 25, 53, and so on. That's 6 separate comparisons for each record. It creates an unnecessary temporary column with extent. Now we will change the good query, which is beautifully optimized. As you can see, we use in with a list of ports, and that's one comparison is instead of the 6. So we collect all the scanned ports using make set. We get immediate visualization too. Okay, so let's move out to trick number 3. This one will help us for botnet and command and control traffic by analyzing user agents. As you can see, the beta approach is what most people try first. You can notice that the multiple contain statements contains nicto or contains nmap, for example, car we get, and so on. This does 5 separate text searches per record. As a final result, you will lose all the context about sources and targets. Now let's check the better approach. Uses KQL powerful features. As you can see, has any with a dynamic list search once, not 5 times. We combine filtering both suspicious agents and attacks. Makeset gives us all the ports and attack types. Argumax shows a real example target. This isn't just faster, it gives us the complete picture of the attack in one query. Trick 4 is a little bit more advanced. It's regarding detecting ICMP tunneling. Attackers sometimes hide data in ICMP packets. Let's have a look on the bad query and why it's inefficient. What you get, it's something that performs math operation. So you can see over 1000 on all ICMP packets. Uses count if instead of filtering early, and groups data it's to granularly. So it's creating hundreds of rows. Now let's have a look how we can fix it. Much better, right? The good query is smart about resources. Filters immediately because protocol counts ICMP and payload size higher than 100. Groups by request type, it's much more mindful. Makeset shows all the conversations and we immediately see which ICMP traffic is suspicious. We can also add and render some chart for management. This visualization will clearly see each payload and total ICMP, also those which counted by its suspicious. So remember, don't do math on the data you're going to throw away. Filter first. Okay, trick number 5. The last but not least, so multi-service attack detection. This finds attackers hitting many different ports. Let's start with something simple. This single pass over data. It filters early and smart aggregation, so gets both count and unique ports. And condition find attackers hitting many targets and multiple ports. Makeset port shows actual ports and not just count. Where to use it? Mainly if you need quick identification of aggressive multi-port attackers. Now let's move on to something more advanced. As you can see, it has richer context. Unique protocols, so are they attacking TCP, UDP, or ICMP? You can see different protocol diversity. Targets, how many victims, attack types, what kind of attacks, makeset scan type, and top user agent, so what tool are you using? It's filtering smarter. Or condition and unique ports higher than 3 or total attacks higher than 10 catches both scenarios, so low volume but diverse attacks, so testing many ports, but also high volume attacks. For example, brute force on few ports. It's more inclusive. Remember, the good query is efficient and gets the job done. It finds attackers with both high volume and port diversity. This is great for catching aggressive, spread out attacks. But the better query takes threat hunting to the next level. Notice three key improvements: richer context, broader detection, and also visualization. So the scatter plot shows outlines instantly. This is something what management loves. Here's the magic. The better query doesn't run slower. It processes the same amount of data once, but gathers way more intelligence. Instead of just counting attacks, we are building a complete attacker profile. Think about it. With the good query, you find an attacker. With the better query, you understand their entire operation, tools, methods, targets, and you see it visually. This is the difference between finding a threat and understanding a threat. Both are single pass queries, but one gives you 10 times more value for the same performance cost.